Types of particular integral. First one, type 1, your RHS, that is q of x, is of the form e power ax, where a is a constant. To write the particular integral, we have to write like this: f of d into e power ax. To solve this, we have to put d equal to a, d equal to a. So your pi equal to 1 divided by f of a, d is replaced by a, so f of a into e power ax if f of a is not equal to 0. Suppose f of a equal to 0, so we have to follow this procedure. Multiply numerator by x, differentiate denominator with respect to d. Once if the denominator becomes 0, we have to follow this procedure. Type 2, if your q of x or RHS equal to sin ax or cos ax, your particular integral can be written as 1 by b square terms we have to concentrate. F of b square into sin ax or cos ax. To solve this, put b square equal to minus a square. So therefore, the particular integral equal to 1 by f of minus a square into sin ax or cos ax. When it is possible, if f of minus a square is not equal to 0, it is possible. Suppose if f of minus a square equal to 0, do the same process. Multiply numerator by x and differentiate denominator with respect to d. Third type, where RHS or your q of x is of the form x power k, where k is an integer. We can write your particular integral as f of d into x power k. To solve this, we can write your pi as 1 divided by your f of d can be replaced by 1 plus or minus some phi of d into x power k. Particular integral equal to, we will take this to the numerator, phi of d the whole inverse into x power k. So we know the formula, 1 plus x the whole inverse equal to 1 minus x plus x square minus x cube plus etc. and 1 minus x the whole inverse equal to 1 x square plus x cube plus etc. Suppose if you have the value minus 2, 1 minus 2x plus 3 x square minus 4 x cube plus etc. 1 minus x whole power minus 2, that is all in the form of positive plus etc. So using this formulas, we can extend the term and multiply by x power k, you will get our required answer. Type 4, q of x or your right hand side term as e power ax into v of x, where v of x is a function of x. That is, it may be in the form of x or it may be in the form of sine or it may be in the form of cos. To write your particular integral, 1 by f of d e power ax into v of x. Solve this, put d by d plus a. Therefore, pi equal to 1 by f of d plus a into v of x. Once if it is replaced, we should write your e power ax in front of the term. Then this term comes under either type 2 or type 3. If this v of x is in the form of sin ax or cos ax, it is type 2. The v of x is of the form x, it will be in the form of type 3. Using this type 2 and type 3, we can solve. Then we can multiply it by what? E power ax. That is our required pi value. Type 5 is q of x equal to or RHS equal to x into v of x. The particular integral can be written as x minus f dash of d divided by f of d into 1 divided by f of d into v of x. So here this 1 by f of d into v of x comes under either type 1, that is e power ax form, or this type 2 sin ax or cos ax form. So applying this and simplifying the term, then again multiply to this and do the same process to get the result.